Hello. So in this demonstration, I'm going to create a loft, and the loft will be between two wireframe entities. The first wireframe entity will be a sine curve, and the second will be a cosine curve. So notice what I have here on the screen. I've got two lines. I've got an axis system and a plane. And what I'm going to do is I'm going to create my sine curve and my cosine curve with the parallel curve tool with the use of laws. So the primary demonstration here is of how to create a law properly to use for that parallel curve tool. So let's begin here. So I'm going to create a sine function, and I'll just give you the parameters here for the sine function. So it will have an amplitude of 10 millimeters. This line, by the way, is 100 millimeters long. So it will be 1.5 revolutions. So the sine function will be 1.5 revolutions with an amplitude of 10, and it'll be a positive sine curve. So let's create that. So I'm going to go to the law tool. So if you're in the Knowledge Advisor workbench, behind the design table, you'll see the law tool. So my first law, I'm going to call this sine, just to make it descriptive. And so in my law editor, I need two formal parameters. One is going to be of type length, and that's going to be the output. So I'm going to call this one, let's call it y of t. Now the reason why is, and you'll see here in just a moment, my formal parameter is going to be a real number of type t. So I've got a length value, formal parameter, and I'm calling it y of t. The next, I'm going to create a formal parameter that is real, of type real. It's going to be a real number. I'm just going to call this one t. So I've got two formal parameters. One is a length value, one is a real number. So when I create this, the function, so I moved over to the editing side, and I can either type in y of t, or I can just double tap it and it will move over. But this is a length value, and CATIA is going to, in the equation, is going to be expecting a length value when the function spits it out, or the function will be expecting a length value. So I mentioned, so this is going to be a sine curve, 1.5 revolutions with an amplitude of 10, and I'm working in millimeters, in radians. But regardless, I'm still going to be very intentional about my units. So I'm going to go 10 millimeters. Now, 10, if I just enter 10, CATIA is thinking, hey, that's 10 real number. So you got to be very intentional about what you tell CATIA when you're working with laws. So you can either type in 10 millimeters, or you can type in 10 times 1 millimeter. And that is taking a real number of 10 and multiplying it by a unit of 1 millimeter, making it 10 millimeters. So right now that would work as far as a curve equation without any issues, because that's a length value, and y of t is a length value. Now I've got to multiply that by my sine function. So inside my sine function, CATIA is expecting an angular unit of measurement. So radians or degrees. So an angular unit of measurement, I'm going to work in radians here. So it's going to be 1.5 revolutions, which is going to be 3 pi radians. So 1 revolution of a circle is 2 pi. I want 1.5 revolutions, so that's going to be 3 times pi is a constant. Now, if I left it just like this, pi is a constant, it's 3.14159 times 3. That's still just a real number. There's nothing magical about the constant pi. It's just a real number. Okay, so don't think that just because I enter pi there that's giving me an angular value. It's still just a real number. So I've got to tell CATIA that is 1 radian, or that is in radians. It's actually 3 pi radians, but that is a unit of measure of radians. And then I got to multiply this by my formal parameter of t, and that formal parameter is going to vary from 0 to 1, so you can think of it as a ratio. So it's going to start out at 0 radians, at the beginning of the curve, the parallel curve, and at the end of the parallel curve at a t-value of 1, it's going to be 3 pi. So it's going to 3 pi radians. So it's going to go from 0 radians to 3 pi radians over that t parameter of 0 to 1. So let's do an apply here. Notice I didn't get any warning messages. Well, let me show you what the warning message would look like if I didn't get my units right. So let's take out the 1 millimeter. Now notice it's saying, hey, your units aren't good, because what's happening here is this is trying to output a real number. So sine will output a real number, 10 is a real number, so 10 times whatever the sine value is going to be, this is a real number and it's expecting a length value. So I got to be very intentional here about making sure that that is going to be a real number. So notice I just multiply the 10 by millimeters, or actually just attach the millimeter unit to the 10, which works as well. So no, and I'm not getting any messages. If I took out the rad, it would be the same thing. It would say, hey, in no uncertain terms, it will go, you're supposed to have an angular value. If I took out the rad, it's just a real number then. So CATIA is going to yell at me. So make sure you get your units right. So let's go to the parallel curve tool. So I'm going to do a parallel curve off of this curve with my XZ as my support. Now I've got a constant value right now of 5 entered in, so you can see an offset of 5 if that's the way I left it, but I'm not. I'm going to go over to the law option, and there are some 3 really predefined options here. You've got a constant, which is what's showing now. It's got a linear type equation in that will allow you to vary a linear curve from some value at the beginning to some value at the end. So notice if I did that, notice I've got an inclined line now. Then it's got a cubic law function built into it that allows me to vary with a point of inflection, a cubic curve. You can see that cubic curve coming in. That's actually can be quite handy for design purposes. And now the one I'm demoing, which is advanced. So when I do advanced, I can come over and pick the law that I created under relations branch on your tree, and then it will graph it for me, and you can see that it's working like I'm expecting. I've got my units right. So if you just didn't pay attention to the warning message CATIA gives you about units not being correct, there's no telling what you're going to have here, right? So you just got to be very careful. So hit that, preview it, there's my sine function, my sine curve, if you will. 1.5 revolutions with an amplitude of 10. So let's do the cosine next. So the cosine will be an amplitude of 10 over 2 revolutions. It's going to be a negative cosine function. So I'm going to go to my law tool, and let's call this, I'll call it negative cosine. Hopefully CATIA will take that name. And so let's do the same principle. I've got a real number, which is going to be my t parameter. Then I've got another formal parameter, which is going to be a length. And let's call that y of, I can't remember what I called it last time. We'll call this one y of t. Doesn't really matter with this one, but I like to be consistent. Let's go t, then u in here of y of t. So over here, work it the same way. Y of t, that's a length value, so the output is expecting to be a length value. I can do negative because it's a negative cosine curve, negative cosine 10 millimeters times cosine, and I'm doing 2 revolutions, so that's going to be 4 times pi. 2 pi is 1 revolution, so that's really 2 times 2 pi. So it just depends on how you want to do it. If you feel comfortable, you can go 2 times 2 times pi. And you know that 2 pi is 1 revolution, so that's 2 revolutions. But I just go ahead and go 4 times pi. And as before, I've got to tell it it's radians. Then I got to put in my t parameter. Just do an apply. No warning messages, which is always good. Parallel curve, you can see it on my tree over here, negative cosine function. So do my parallel curve. So I've got a curve and my support. Notice that's why I had to put this plane here, is because I need the support on the line. So if I, just one of the things about CATIA. So, and then I'll come over to the law, definition, and then I can do advanced, and I can select that law function. You can see it graphed, it's looking good. I got good amplitude values. All is looking great. Preview it, and there's my negative cosine function. And then if I wanted to do whatever I wanted to do between these, I can do a blend. I think I said I was going to do a loft, so let's get real fancy with this. I'm going to create a geometric set here, and I'm going to call this surfaces. So let's create a extrusion. I'll create an extrusion there, and let's go, looks like Y direction. Reverse that. I'll do an extrusion over here. Also in the Y direction. Now let's do, you can do a loft, you can do a blend. Let's do a blend instead of a loft. So I'm going to hide some of this stuff. I'm actually going to hide my axis system so that this will make it somewhat interesting, I think. So let's do I like interesting. So let's try a blend here. So I'm going to go from that curve with the support of this surface to this curve with the support of this surface. And let's preview it. And notice how I've got a nice blend, kind of a loft between the two. And continuity, I've got, you still got point, tangency, curvature, G0, G1, G2. Let's make it curvature. And my edges, you always have to pay attention to your edges. Are they coming? How are they coming? I think they're looking good there. So when it says both extremes, you are getting tangencies along the edges as well, which is good. So that is, notice how I've got a lofted surface between a sine curve and a cosine curve. Again, interesting, right? Makes it interesting. You can do the same thing with a loft, but the key thing for this demonstration is showing how to do the laws with sine and cosine, and making sure your units are correct. And if you get that warning message about your units not being correct, make sure you fix it. It's going to make a more robust model in the end. Thanks. Have a great day.